So this is another quick and dirty video on how to 3D print at the Idea Foundry in anticipation of Startup Weekend. And this is not intended to leave you as an expert designer, expert 3D printer, but rather to teach you what you don't know in order to design for these kinds of things. So first off, you'll need a 3D file, and there are two main types of 3D files. Parametric, in which all the shapes can be changed by changing a parameter. So the diameter of a circle is parametric. Versus NURBS. NURBS is a funny word. It's obviously an acronym. And this is more sculptural kind of shapes, very organic shapes that you can carve digitally and then 3D print. We will also talk about the two types of 3D printing technology. There's fused deposition modeling, or FDM. That's kind of like a hot glue gun controlled by computer. And then there's also stereolithographic additive, or SLA. That's essentially magic lasers tracing your shape through a liquid resin. Where if the laser touches the liquid, it cures it. We'll talk about these different technologies, pros and cons. We'll talk about rough build times for projects that we'll be making that weekend. Probably the shortest 3D print period might only be half an hour. The longest might be 2 or 3 hours, and that won't build a very large shape. The build envelopes for these machines are pretty small too, just a few inches by a few inches. Think something the size of a mouse or a wearable, that's a computer mouse, or a wearable wristband. You're not going to be 3D printing a chair. You might 3D print a single shoe. And then we'll talk about the fact that these aren't perfect machines, and that the products will require a little bit of post-printing cleanup afterwards. So hopefully educate you about some of these phenomena. So first we'll talk about FDM, and here we have a little video animation courtesy of this YouTube link here. I'm going to turn the volume down. This is a computer simulation that shows what it's like when that plastic filament gets heated up and extruded through a little heated filament extruder. So this is essentially painting of one layer of a 3D shape by extruding molten plastic, and once it comes out of the extruder, it then solidifies. So even though we're zoomed in here on the simulation, you can see that the filament has a certain curvature. When you take a step back, that layer essentially looks flat. So it's as if you were taking a hot glue gun and building up an object layer by layer, or if you're a baker with your frosting bag, squirting frosting out and creating a 3D flower, or printing lettering, things like that. It's the same kind of technique. And you can see that since each layer is built up on the layer beneath it, you can't have too much overhang. You can't have too much of what we call the inverted pyramid problem. It's about 45 degrees that you can build up on. If you're trying to make something with a steeper shelf than that, then you're going to have some trouble. You might need to put in what's called support structure or support material, and some of the software will help you do that. We'll show some of that later in these videos. And here we have an example of an object being printed with FDM, and it's going to be a reindeer printed on an Ultimaker 3D printer. We have one of these machines at the shop. So first you make these pads to build up onto the build platform, and then we can see the legs of the reindeer are being added here. Shortly we'll skip ahead towards the end of the reindeer, but you can see that with FDM, with this fused deposition modeling, you can only squirt out a bit of that filament at a time. You can't print multiple shapes simultaneously. So when it's painting, as it were, this leg, it then pauses and then paints this one, and then pauses and paints this one, and pauses and does this one. This is opposed to the other type of technology we're going to be talking about, SLA, which can build up almost simultaneously. So here we've skipped ahead a bit. Oh, let me turn the music down. And now we're towards the end of the reindeer. Here, I just want to point out, you can see a little bit of kind of messy plastic that didn't quite get pinched off when the extruder moved from spot to spot. We can also see how the reindeer antlers here are moving up and down a little bit as the print head is pushing them and is squirting out more molten plastic. So if you had to make something with very high precision, very high tolerance, like snap together enclosures or things that need to press fit, there's a little bit of art there to it. And we can see that as these antlers are being made, you can see this kind of spider web, wispy ligands or extra strands of molten plastic that didn't quite get pinched off. So sometimes there will be a little bit of sanding, a little bit of polishing, a little bit of actually snipping off big pieces of plastic that didn't get disconnected. So like I said, you don't always get the perfect part off these machines each time. It takes a little bit of cleanup afterwards. But clearly you can make some amazing 3D sculptural shapes. Now the other technology is this SLA, and here, make sure my volume is down. We'll watch this video. This is another simulation. Essentially a laser shines on a couple of mirrors, and those mirrors are controlled by computer, and they raster out, or they draw a shape, every layer, in this liquid resin. And this is a way to get retail ready, very pretty shapes. It's a little bit slower process, a higher resolution. It's a more expensive material, but you can make really amazing things with this tech. And here I will turn the volume up. I'll make sure I'm capturing my machine.
The Form 1 Plus is a stereolithography 3D printer. Today, we're going to take a look at how it works and put it to the test against parts from an extrusion-based machine. Let's start by taking a closer look at the printer. When we open up the light-blocking cover, we can see a build platform inside. This metal plate is where the parts are made. Underneath the build platform is a resin tank. This clear window gives the ultraviolet laser a path to cure the resin. To start a print, we'll upload a file and fill up the resin tank to the indicator line. You can see the laser passing back and forth inside, hardening the liquid plastic. We'll take our printout and wash it in rubbing alcohol to get the excess resin off. The flower comes with supports on it, and we'll snip them off to finish the piece. Stereolithography is known for producing extreme detail with layers down to 4 times finer than a human hair. The Form 1 Plus lets us take advantage of a library of materials, so we made some other parts to show what these resins can do. A castable resin gives jewelers and engineers an inexpensive way to produce metal parts. This flexible resin is great for simulating different textures, and as we can see, this tough resin can really take a hit. Now let's compare how the Form 1 Plus parts stand up against a filament printer. The stereolithography part comes out nice and smooth, but we can see and feel the ridges on the cup printed with filament. When we break this sample piece, you can see that filament parts quickly snap along the layer lines. The SLA process creates a chemical bond, so our prints take much more force. Today, we took a look at how stereolithography printers work, the types of resins they can print with, and what makes the parts stand out against other desktop machines. If you liked our intro to
So we talked about the filament or fused deposition modeling machines. We talked about the SLA, stereolithographic liquid resin machines. Now we need to talk a bit about how you create the 3D files, which are the inputs for those machines. If you have a PC, a laptop, a Mac, we recommend Fusion 360. It's a free software program, 3D design program put out by Autodesk. It's free for enthusiasts, hobbyists, and educators. There's also Sculptress, which is a great 3D sculpting program. There are also some others. Tinkercad is a great one. Blender is a great one. We'll include a separate link to all the free resources we recommend. But there are also some amazing virtual reality apps. The Oculus Rift has a software program called Medium that's great for 3D sculpting virtually. The HTC Vive has a great app for painting, 3D painting. It also has some sculpting softwares, and we'll make those available as well. So the next few videos we'll talk about 3D design for these machines.